Hello dear students, welcome back to my masterclass, and this time the masterclass is on Newton's laws of motion. So first of all, thank you so much for all your great responses and the love that all of you have provided me. And again, let's have one more experience of Vedantu Master Classes, the fusion of the best teachers and the best of technology. So my dear students, one thing that I would like to request you is, please ensure that you have a pen and paper handy so that you can make a note of everything that is important in this masterclass. Let me also tell you that by the end of this masterclass, as usual, we will have two surprise gifts for all of you. One will help you tremendously in your aspirations, and let me tell you, the second surprise is something which is beyond compare, which I give to all my students. And again, to put it in words, I think it is even difficult for you to begin to imagine how much it will help you in your lives. So again, hold on for that. We will be disclosing that by the end of the masterclass, which is of 1 hour. Let me tell you, my name is Namokal. I am taking this masterclass from Bangalore. Let me also tell you, my dear students, that I have close to 8.5 years of teaching and mentoring students for JEE Physics. I'm also the proud inventor of Turbo Math. I have taught and mentored close to tens of thousands of students online and offline. Let me also tell you that I have been certified by the Indian Association of Physics Teachers. But again, all these are just credentials. In life, what is most important is that we implement whatever we love. So let me tell you, students, I mean, all these things don't matter to me much, but again, your love towards me and my love towards you, and again, all these master classes, they matter the most. And again, from the bottom of my heart, let me tell you, students, that today's session is going to be phenomenal, and I want you to visualize everything in today's class, because Newton's laws of motion is one subject in physics, after which I tell all my kids not to overdo physics. Okay, so having said that, let's get the party started and let's go. So let's see what we have. Okay, so before we get started, let me tell you some of the things that comprises or makes Newton's laws of motion. Again, you all know there was an apple which fell on Newton's head, and then after the apple fell, there were some laws that were made. So again, what we will be studying today will be basic forces. And again, not everything, but let's see what all we can accommodate. But this beautiful chapter comprises of the concept of weighing machine in different scenarios, that what will be your weight in a moving lift and many such scenarios. Motion of an object on an inclined plane. Now, if this is an incline or a wedge of angle theta, what is the motion, what is the acceleration? This is what it comprises of. It has numerous string and pulley based problems. And let me tell you, students, after today's class, I think many of the problems, advanced problems, you will be able to solve just in seconds. And again, in this, we also have the concepts of constraint motion, something like this, a bead moving over the a string like this, a ladder sliding because of two walls, and a situation like this, and many such examples. It also comprises of pulley block, constraint motion based problems, and pseudo force, something that does not exist but we feel, and obviously the Hooke's law or the Springs force. How do we get that? We will also have the famous string cut problems. So these are the favorite questions of JEE Advanced and obviously in NEET as well. Also the composite springs, that if I have a lot of strings, how can I find the equivalent springs constant? So these are numerous things that Newton's laws of motion comprises of. And let's see how we can have fun with problems of Newton's laws of motion. Chalo, let's get started. So again, let's start with a basic fundamental. We'll not start with force, but we will start with linear momentum. Because what is linear momentum? Please see. What is linear momentum? Is a vector. Okay, so we all know linear momentum is a vector which is denoted by P. So this is a vector. And we also know linear momentum and velocity are bhai. Okay, so they are brothers. So this is velocity. So what is momentum? So now this is a truck which has a very high mass. Okay, so the mass of this truck is M, capital M. So what will be the momentum of this truck? Momentum of the truck is equals to mass into the velocity of the truck. So momentum is defined as mass, which is obviously a scalar, it's a number, into the velocity. So these are parallel vectors. So the momentum vector of this truck, obviously if the mass is greater than 1 kg, it will be something like this. So it's a bigger vector, so they are parallel vectors. So again, if there is momentum, there is velocity. If there is velocity, there is momentum. So they have to coexist. So this is a very important part. And how do we get force? Let me tell you. Just because of this relationship, we get force also. If you differentiate this with respect to time, let's see what we get. So what we just studied is mathematically P vector, linear momentum vector, is equals to mass into velocity vector. Again, we can clearly see momentum is a vector. Magnitude is equals to mv, kg meters per second is the SI unit, and direction is along the velocity's direction, because obviously these are parallel vectors. Now let's differentiate this, my dear students. Let's differentiate this with respect to time. Okay? Okay, so when we differentiate it, we put d by dt on both the sides. Rate of change of linear momentum is equals to rate of change of, now this is the most important part which many books don't mention, but understand this is mv. So now let me tell you, in majority of the cases mass does not change, but the mass can also change, and because of dm by dt, rate of change of mass, you can also experience thrust force. So if you take mass as constant, so here I am taking mass as constant, so I take m outside into d v by dt. If mass is changing, then you'll have to apply product rule. Here I am saying mass is a constant. Okay, so I've taken it outside. So this is dp by dt is equals to m into dv by dt. Now everyone should know that dv by dt, we all know, right? It is the rate of change of velocity vector, right? Which is acceleration. So this is equals to mass into acceleration. Now this is something which most of us are more familiar with. So what is mass into acceleration? This is force, right? Force is equals to mass into acceleration. So this is another way to define force. Actually, a more precise way of defining force is that the force is the rate of change of, force is defined as the rate of change of linear momentum. Okay, so force is the rate of change of linear momentum, and the SI unit is kg into meters per second. So this is how we define force. Now let's get into forces. So by the way, again, if we just talk about forces in general, we know two forces. We've experienced two type of forces. One is the contact forces. If I push, pull or twist something, so those forces are contact based forces. Like I pick up this object over here. So I picked it up because I applied some force, right? And now this is, here you can see that this is a case of non-contact force. So we all know that because of a magnet, this is levitating, and the object is experiencing a force without any contact. So we have seen and experienced such forces. For example, if we have two magnets in our hand and they are repelling, we can feel that force without any contact. Now let's have a look at some of the forces that we are aware of. Something like a ball hitting a bat. If we compress a spring or if we extend a spring, what happens? We feel a force, and then a drag force that is experienced by a parachute or an airplane. The friction force which ensures that we don't slip, and again the normal force. Now most of us don't know what normal force is. We will have a look at what normal force is very soon. Then magnetic force, because of the magnets, electric force, like if you have two charges Q1 and Q2, and if they are like charges, they will repel each other according to the law K Q1 Q2 upon R square. Similarly, gravitational force, because of which the apple had fallen on Newton's head, and obviously then Newton definitely took revenge, and that was a good revenge. We have Newton's laws after that. Now let's have a look at basic forces that we are going to study today, that we are going to encounter today. That is, first is the weight of the body. Always remember, this is a gravitational force and it is always attractive in nature. For example, if this is an object, it falls down, and where does it fall down? It falls down towards the center of the earth, jo niche hai, because we are on a sphere. So the center of the earth is always below us. So everything falls down because of this force. You can see, because of this force, this is moving and going down. So that is the weight of the body. And again, what is tension force? So basically this is an attractive force. Where does it act? Direction is towards center of our planet, Mother Earth. ठीक है? अब tension force को देखते हैं. Now the best way, please have a look at this string. I think all of you can have a look at this string. Now this string is not exerting any force. It is kind of dead. तो tension only comes when something is tight. Okay, for example, if circumstances in our life are tight, we obviously experience tension. Similarly, this string, so right now no force, so there is no tension, but as I extend it like this, it becomes tight. So my hands should go left and right, but because of the tension force, which is a pulling force, my hands do not separate. As I leave it, my hands kind of separate. Okay, let me get this back. So tension is a pulling force. The best example why it is not a pushing force, अब देखो इससे push कर सकते हो तुम, like if you have a rope like this, can you push with this? It's kind of dead. So tension is always a pulling force. The tension is being I can experience the tension because it is acting along the string and it is a pulling force. It is pulling my hand here and this hand over here. So tension acts along the string and it is a pulling force. तो यहाँ पे लिख देते हैं it is pulling in nature. Similarly, अब देखते हैं normal force. Now normal force, normally we don't talk about it. Nobody has usually told us about it, but still let's see what is a normal force. Now everybody knows that this object, if I just leave it, it will fall. But right now, when it is lying on my hand, please see, when it is lying on my hand, what is happening? The forces, visualize the forces. So one force is mg acting downwards, okay? But because of mg, it is not falling because of my hand, what is happening? There is a force in the upward direction which is balancing mg, okay? Which is balancing mg, and that is a contact force normal to the surface. And because normal matlab perpendicular, that is why we call it normal force. It is a contact force. If there is a contact, there is a normal force. For example, if you are in an auto rickshaw or if you are in probably a bus and many people are around you, so there is a lot of contact, so you feel a lot of normal reactions, okay? Probably in a mob जहाँ पे भीड़ होती है, you feel a lot of normal force. And normal is a push based force, understand? Normal is a push based force, ठीक है? So this is a pushing force by nature, this is a pulling force, and this is towards the center of the earth. This is also like a gravitational pull, ठीक है? So now understanding this, abhi let's do a quick activity. This is a mass m, this is a mass m, and acceleration due to gravity is downward, okay? So because earth का center नीचे ही होता है. Now everybody, let's mark the weight forces or the force of gravity will be downwards. तो यहाँ पे because of the gravity is acting downwards, the force will be m into g, ठीक है? And here the force will be m into g. So these are the forces. Similarly, now let's also mark some normal reaction forces in this scenario. So normal is always normal to the surface, okay? Normal to the surface. So let's have a look now. So this is a mass m and ये ground है, and this block is not going down because the ground is there. So one force is mg, but I'm only marking normal reaction in this. So normal force will be perpendicular to the surface like this. So this will be one normal reaction. For this mass, how will I draw the normal reaction? It will be normal to this surface, okay? So the normal reaction will act like this, n, okay? So this is n2. Similarly, here there are two contacts, one here and one here. So let me draw those normal reactions also. But again, remember, if it's a circle, and again on a circle, if you draw a tangent, and tangent is the surface, so if you draw a normal to the tangent, it will pass through the center. So that's a property of the circle. So normal reactions will also pass through the center, both of these normal reactions, okay? Their magnitude might be different, but they will look like this, n3 and n4, okay? So these will be the forces, n3 and n4 passing through the center of the circle. Now this can be a disc, it can be a sphere or a cylinder, anything which has circle, which looks circular in 2D. Now let's have a look at this case. Now for example, अगर एक ladder है, or if there is a stick like this which is resting on two walls, तो अब normal reaction कहाँ है? So there are two contacts, one here and one here. So this is like a notch, right? Understand? So here the normal reactions will be normal to this surface. So one normal reaction will be like this, n1, and here the other one will be n2. Now they will be normal to this surface, okay? Now let's have a look at this scenario where it is protruding outwards. So now this is a case which is missed out most of the places. This is an advanced case. So let's have a look, but बहुत simple है. So here, so you can clearly see this is the surface. So normal reaction यहाँ पे लगेगा. So let's call this normal reaction n3. And here, now understand, how do you visualize this? Here, take this as the surface and take this as the notch. So in this case, what happens is the normal reaction does not act like this. ये ऐसे नहीं act करेगा. So it will act like this. So if you understand the direction, I think that is the most critical thing here. So this will be the normal reaction. So this is just getting the feel of how the forces are acting and visualizing those forces. Are these the only forces? No, there is an mg force also here. In all the cases, I did not draw mg because we were only marking the normal forces. Okay, so here also let's draw the normal reaction. So here this is a contact, this is a contact. Again, perpendicular will pass through the center here like this. Okay. So this will be N1 and this will be N2. If you also want to mark the force of gravity or the weight force, it will be like this, mg. So now the beauty is, if something is lying there and only lying there, that means all the three forces are balanced, and which is again quite convenient to understand, right? There is one vector here, and one vector here. The sum of all those vectors is 0 because normal is an adjustable force. वो उतना ही लगता है how much it is needed. For example, if I keep the object like this on my hand, right now what is the normal reaction? It is equal to the weight. If I press more, the normal reaction is increasing. So it is an adjustable force. So understand that. Now let's move on. Now tension forces. Now what did I say? Tension force is denoted by T. Okay, like normal was denoted by N. What was weight? Weight was mg. Similarly, if there's a string, we denote that tension force by the letter T. अब यहाँ पे let's see what are the forces. Let's draw the forces. So two strings, two tensions. ठीक है. So for one string, I'm drawing the tension T1. So this is one force. Visualize this force, everyone. Similarly, there will also be another force because of this tension. So let's call this as T2, and this one will be mg. Again, we'll study this later, that if this is symmetric, if these strings are symmetric, both the tensions will also be same in magnitude. That means if this angle is equal to this angle. Now let's have a look at another case like this. So here let's draw all the forces that we can think of. So everyone, on this bob, obviously on this ball over here, one force will be mg. Okay, one force will be mg. There is also a normal reaction here. Okay, so here there will also be one more force, which is the normal, and obviously because of the string there will be another force, which is the tension. So this is the tension force, and because of these three forces being balanced, the ball stays over there. Let's also have a look at this mass over here. यहाँ पे what are the forces? So there is one tension force here because of the string. Tension is a pulling force. So this is T1. This is another string, so another tension. So let's call this as T2, and this will be mg. Okay, so these are the three forces that we can visualize over here. Okay, now this is the first question for all of you. Let's see who's the quickest here. So find the number of forces on the wedge A. So there is a wedge A. How many forces can you visualize and count that are acting on the wedge A? Okay, I'll be giving you 20 seconds for this question. Okay, 12 more seconds to go. 10, 9, 8, 7, 6, 5, 4, 3, 2 and 1. The correct answer, my dear students, for this question was D5. Okay, so Delhi is the correct answer for this question. So here everyone, how do you visualize? So basically क्या forces लग रहे हैं on the wedge? So if I kind of draw the free body diagram. Now what is a free body diagram? Don't get confused if you don't know what it is. बहुत simple चीज होती है. That means you free the body and draw the forces. So I freed the body from everything. And now this body पे let's visualize what are the forces. So यहाँ पे there is how many contacts are there? उतने ही contact forces होंगे. So this is one contact. This is contact number 2 with the ball. This is contact number 3 with the floor. With this wall, contact number 4. So 4 normal reactions on the wedge, okay, pushing forces, and one weight. So 5. So let me draw those all the forces, all the 5 forces. So one will be the weight mg. So a crystal clear understanding, everyone. तो यहाँ से normal 1 लगेगा. So this is a pushing force. Everyone see normal लगेगा यहाँ पे n1, and here this will be n2. So it will act like this. N2, and because of this I'll have N3 over here. Because of the wall I will have N4. and if this is in equilibrium, nothing is moving, that means all these forces will beautifully balance themselves. So that is how nature shows how we can be at rest. Okay, so this is about the first question. Now let's test our understanding of vectors with Newton's laws. So everyone visualize forces, and the question is as simple as this. Find the tension in the string. In this string you have to find the tension if the mass of the ball is 1.2 kg, and take gravity as 10 here, take gravity as 10 meters per second square, and the radius is 3. So basically it is given that the radius, let's call this as the radius. So this radius is 3 meters, and the length of the string, my dear students, the length of the string is 5 meters. So if this length is 5, if the radius is 3, you have to find what is the tension in the string. Okay, so let me help you visualize the forces. So is ball pe, now this ball is not moving. So on this ball, what are the three forces? One is the tension, one is the weight, and because it is touching the wall, so one normal. So you can now see that all the three forces will be balanced. By balancing the forces, by understanding how they will balance, you can easily find the answer to this question. Now let's have a look. Let's draw the free body diagram. First, free it from the wall, free it from everyone else, and then we will study things neatly. So free body diagram का मतलब भी यही होता है that you do things in a neat fashion. So everyone, now let's have a look. तो यहाँ पे now if you see, this is 3, this is 5, so ये 3 4 5 वाला triangle है, so this will be 4. So 3 4 5, and again using trigonometry you can easily find what this angle will be. So this angle will be 37 degrees. This angle will be 37 degrees. Why? Because sine 37 is 3 by 5, right? So it is an angle, it is the famous triangle of 3 4 5 जो examiners के favorite होते हैं. So this is 3 4 5 वाला triangle. Everyone look at the tension force. So the tension force will act like this along the string. So this will be the tension force. There will be a normal force on the right. So let me draw the normal force. For simplicity, I am moving the vector here. So this is the normal force, and the weight force will be downwards. Okay? What will be the weight force equal to mg, right? 1.2 into 10. So mg, which will be equal to 12 Newton in our case. So this is 12 Newton. Let me just write 12, not n, because n is normal reaction for us. Okay, so now let's balance the forces. Now all of us know कि ये angle क्या होगा. So if you look at this, basically with this normal, this will also be 37 degrees. So this is also 37 degrees. Okay, so let's break the force of tension and balance the forces in x and y. Okay, if this is x and this is y, that's how simple this is. So t cosine sticks, right? So t cos 37, so t cos 37 and t sine 37. So tension ko I have broken it down into two vectors, t sine 37, sorry, t cos 37 and t sine 37. So that is how we resolve vectors. So this is the most important part that we learned in vectors as well. So here I have broken this tension into t cos 37 degrees, और यहाँ पे the tension force will be t sine 37 degrees. So I have broken it down into two things. Now numerically, what is cos 37? It will be 4t by 5, and this numerically will be equal to 3t by 5. So basically this entire thing is equivalent to 4 forces. Just balance those 4 forces. One force will be equal to 4t by 5, and the downward force will be equal to 12 Newton, and here it will be the normal reaction, and here it will be the 3t by 5. We have to find the tension in the string, right? The tension in the string. So we just balance this and this. If someone asked us what the normal reaction is, that also you can find. So let's find both. First, balance these two. These two will, because it's not moving, so this force is equals to this force, and this force is equals to this force. So balance the forces because of equilibrium condition. 4t by 5 is equals to 12. So 4 3s are, so tension is equals to 15 Newton. So your correct answer to this question will be B 15. Okay, the normal क्या होगा? Now you can take out what the value of normal will also be. So normal will be equal to 3t by 5. Put in the value of tension. So this will be equal to 3 into 15 by 5, which will be equal to 9, right? 5 3s are 15, 9 Newton. Okay, so I hope you all understood how to do a problem like this. So great. Now let's increase the level and let's have a look at the next question. So this is a very similar question. Here you have three strings, one string, the second string, and the third string. And you have to find the tension in the horizontal string. So that means you have to find the tension here. Now let's quickly solve this question like a pro. Isme tension, let's call the tension here is T, and here let's say the tension is T1 in this string, and in this string it is T2. So if you just look at this string, what will be the tension in the string T2? So here on this block, the weight will be 120 Newton and the tension is a pulling force. So it will pull the 12 kg block. So T2 though you can easily find out by balancing this block. Okay, so T2 will be equal to 120 Newton. So T2 ka value is 120 Newton. And similarly, what is the value of T and T1? Now we will have a look. So basically for finding out this, you have to analyze this point, balance all the forces here because everything is in equilibrium. So all these forces, this tension T1 and T2, all should nullify each other. Okay, so here the horizontal tension is on this point is T here. T1 is acting at an angle of, ये क्या angle है? What is this angle? This angle is 53 degrees, right? Because this is 90, 37, so this will be 53. Or you can have a look at this angle, no problem. इसको ले लेते हैं. This is 37 degrees. So यहाँ पे, if you see, T1 is acting at an angle of 37 degrees, okay? And then we have the weight. Weight is 120 Newton. Okay, amazing. So if you have a look, students, you can break this tension T1 into T1 cos 37 and the other one will be T1 sin 37. So isko break kar do. You can easily break it. So this one will be T1 cos 37 degrees and this other one will be T1 sin 37 degrees. It's very easy. This vector cos 37 because cosine sticks. The other one is sin 37. तो यहाँ पे इसको हटा दो. Okay, because you cannot have both. You've broken a vector into two vectors. So you either keep these or you keep this. So it is equivalent. So now balance the horizontal forces and the vertical forces. So vertical forces ko balance karne se what do we get? So I get T1 sin 37 is what? Sin 37 is 3 by 5 is equals to 120. So this will be 340 za. So T1 will be equal to 4 5 za 20. So this will be 200 Newton. So this is the tension in this string T1, but our answer is T. Okay, now let's balance this and this. So when you balance T1 cos 37 degrees equals to T, तो T1 का value put कर दो यहाँ पे 200 cos 37 will be 4 by 5. So 5 4s are 20. Okay, so this is equals to T. So tension is equals to 160 Newton. Is there an option? Yes, there is. B option is your correct answer. Now let's move on. Okay, now we have seen a lot of problems on tension, and here we see something new has been introduced, and that is a massless pulley. Now understand, till now we have whatever strings we have seen are ideal strings, and whatever pulleys we have seen are ideal pulleys. Now what are ideal pulleys and ideal strings? So ideal strings are the ones which you cannot extend. So again, they are not like rubber band that they will extend. So they don't extend, and the second thing is that they are massless. They don't have any mass in them. So that is why the tension throughout the string will be constant. Okay, so यहाँ पे देखो. So even this is a massless pulley and this is an ideal massless string. So here what is given? Consider the system of ideal pulley as shown. The mass is M attached with the help of an ideal string. Find the force exerted by the pulley on the ceiling. So basically what they are asking you is कि what is the force exerted by the pulley on the ceiling. Basically अगर यहाँ पे if you say that the tension in the string is T, okay, अगर यहाँ पे tension is T, so what happens is it is being pulled by T, right? Because obviously in a string, if the tension is T on the ceiling, if this is the ceiling and the tension is T, so the force on the ceiling will be equal to T, right? So you have to find what this T is. Now the best way to find that is very simple. So यहाँ पे two different strings are there, this string and this string. So let's say that the tension in this string is T. So यहाँ पे भी T हो जाएगा. It is the same string. and on this string it will be equal to 2t. I will tell you why. Because if you look at the massless pulley, now this pulley's mass is equal to 0, and tension is a pulling force. Because of this tension, it will pull it here, and because the string is on this side also, so here also the tension will be T. So the net downward force is 2T. So if the tension in the above string is say T1, agar ye T1 hai, T1, this is also a pulling force. And because it is massless, because of force is equals to mass into acceleration, if mass is 0, then the net force also should be 0. So again, that is how nature adjusts itself when the mass is 0. But again, in nature we don't have anything where mass is 0. It is just to study it. So if the mass is equal to 0, the net forces will be 0. Ye samajh lo. So here you can easily balance that T1 is equals to T plus T. So that is why T1 is equals to 2T. Or you can directly write, यहाँ पे TT है, तो because it is massless, forces will be balanced. So this will be equal to 2T. So if this is TT, this will be 2T. Now what is your answer? Your answer is what is the value of 2T. अब यहाँ पे look at this block. यहाँ पे this is mg force and this is tension T force. So you can easily balance the forces here. For this block, T is equals to mg, and your answer is 2T is equals to 2mg. Okay, from this. So your answer was 2T, right? Which is equals to 2mg. So B option orally you can get. अब देखो how I would have approached this problem. Let me tell you. So I would have approached it in a different way. I would say, okay, this is M, and this M mass is not moving. It's an equilibrium wala problem. So here this mass is having mg force, and this is tension T. So the tension in this entire string will be equal to mg. So this is mg. So here 2mg. Okay, so that is why I'll directly take without even lifting my pen for this problem. I hope all of you did it without lifting your pens. Chalo, great. So now students, let me tell you some tricks which will help you tremendously, especially for your NEET examination and JEE Advanced. So these are some constrained motion tricks which definitely will help you all pulley based problems in seconds. Okay, so now let's have a look at the first illustration. So this is an illustration which can be solved using vectors, and after two such illustrations we will be discussing those tricks. One or two. So now let's have a look at what will be the velocity of the bead. Try this out. So if I'm pulling the string with 2 meters per second, if this string is being pulled down by 2 meters per second, what will be the velocity of the bead? Now the best thing about this problem is I already know that many of you will either give me the answer of 1 or 4. But again, the point is which is the correct answer, and I will tell you a God way of solving this problem. Just like that. So what is the vector way? First have a look at that, everyone. Okay, so what is the vector way? So this point has a velocity of 2 downwards. So this point will also have 2, 2, 2. So you can just make this 2 travel. So this point's velocity will also be 2. This point will also be 2. So you're just traveling. So this point's velocity is what? This point's velocity is also 2. Now, and this, and you know, if you want to find the velocity of the bead, now you know because of the constraint. Now you just have to visualize where the bead will go. Bead will go follow this, right? It will go horizontally because of the constraint. So what is the resultant velocity of the bead? What is the BAP velocity of bead? So basically, yes. So this is the BAP velocity. So this is the resultant velocity. We know because of visualization कि bead यहाँ जाएगा. So this is the resultant. Just understand using vectors. This is just a component. This 2 wala velocity is just a component, or इससे you can easily find out. So V has to be greater than 2 for sure. Okay, so this is the resultant. So you can easily say this is one of the hacks, one of the tricks. V cos 60 degrees 1 second में you can write is equals to 2, because V इसका एक component है ये. So V is the resultant velocity. One of the components is 2. So you write V cos 60 degrees is equals to 2. But ask yourself this question, is this the resultant or this is the resultant? But because you know the bead is going to go here, and that is how you easily solve the problem. So here V cos 60 degrees, cos 60 degree क्या होता है? It will be half is equals to 2. So your answer is equals to 4. So this is one way of solving this problem. There is another way of appreciating the solution for this. So the other way is not that straightforward, but again very simple to understand. It is something like this. Ki what is the velocity of the ends of the string? Now the string will not, the string's length will not change. Okay, it is an inextensible string. So along the length, if you say this will be v cos 60, v cos 60 degrees, the velocity along, and here the velocity at this end will be 2. So velocity is, so basically the length of the string is increasing by 2 meters here and v cos 60 here. So this is increase, this is decrease. So increase should be equal to decrease. So this is another way of equating these two. But if you ask me, this is a much more elegant way of solving the problem. You can also solve it using calculus, but again, that will take a lot of time and energy. So now we can easily understand why the correct answer will be 4. So there will be a lot of students which will give the answer as 1 meters per second, but that is absolutely absurd. Okay, so with that, now let's have a look at one of the advanced illustrations. Now, why do I call this advanced? Actually, this is a very chindi or a bacha problem, I would say. Kyunki this problem is advanced because it has been seen in one of the JEE advanced papers. And again, let me tell you what makes this advanced is because of the options. Because you see 2 options and you will either give the answer as, let me tell you beforehand, B or C. Okay, there is no other go. But how do you solve this question with the same killer visualization? Let me give you a glimpse of that. So everyone, this is the first see the problem. Both of the strings are being pulled by you. Now it's a very symmetric problem, तो ये u से नीचे आ रहा है. So just answer this question कि mass m, where will it go? Will it go something like this, or something like this? Yes, everyone is right. The mass m will go perfectly upar. Okay, it will move upwards, and it is given also in the problem. So basically mass m की resultant velocity, like I said, resultant velocity will be here. So here you will get crystal clarity. So this is the resultant velocity that we have to find. Okay, v we have to find. This is the resultant velocity. Now let's travel any velocity. So ये v है, so ये u है, so ये भी u होगा. So if you travel, this will also be u. So this will also be equal to u. Now this is just a component, understand, because we know for sure, we can visualize that the block is moving here. So the resultant velocity is v, which we have to find, but one of the components of this velocity is u. Okay? So what will you write? V is the resultant velocity, v cos theta. Cos theta is a fraction right here. V cos theta is equals to u. That's it. बस इसको लिखना सीख लो. V cos theta will be equal to u. So what is the value of v? V is equals to u by cos theta, which will be your answer, or u sec theta. Okay, I hope everyone understood this. So this is a very easy question. Okay, so there are many other ways of also understanding it. If this velocity is v and the velocity along the length of this string will be v cos theta, so the string is decreasing by v cos theta and increasing by u. So increase is equals to decrease because the length is constant. Now let's also have a look at the first trick that I'm going to teach you. Now this first trick is a universal trick which will always, you can apply this for any pulley system. And again, one thing that has to be understood is that all the strings should be ideal. Okay, so what does it say? So the thing is that the net work done by a massless string on the blocks that are given in the problem will always be 0. Understand that. So this is something which we can understand very easily. But before that, what is work? Work is force dot display. It's the dot product of the force and the displacement. Now let's have a look at this Atwood machine here. Atwood machine matlab, what is an Atwood machine? A pulley and two masses here. Okay, pulley is massless and even the strings are massless or ideal. So here, if this block goes up, now the tension is T. So if the block goes up by X, this block will come down by X. Easy. If this block moves up by X, this will move down by X. So what is the work done by tension here? Tension and displacement are in the same direction. So it will be T into X into cos 0, dot product. Okay, Tx. What will be the work done? In this case, tension is upwards, but the displacement is downwards. So 180 degree angle. So T into X into cos 180 degrees. So here the work done by the tension will be minus Tx because T into X into minus 1 cos 180 degrees. So the net work done is 0. If you can clearly see the net work done is 0. So you can establish this very easily that the summation of all the tension dot, now this is a dot product, not just a product, it is dot product, tension dot x will be equal to 0. Okay. Now all you have to understand is if you differentiate this with respect to time, okay, if you differentiate this with respect to time, you will also be able to establish that the dot product of the tension with the velocities will be 0. And if you differentiate it once more, you will be able to establish that the tension's dot product with the acceleration will also be equal to 0. Okay, so this is what we learn from the tension trick. How do we apply it? It's very simple. Once we have a look at some problems, you will see how quickly you'll be able to solve problems with using this trick. So this is trick number 1. Now let me also teach you one more trick, which is the pulley trick. Okay, and wait till we apply all these techniques. So what is the pulley trick? Pulley trick is very simple. For example, here, if you have a pulley like this, okay, and here there is, say, one mass here, and this pulley is attached to another pulley. Let's say it is attached to one more pulley, and this is also fixed, and something like, it can be as complex a structure. So but at any point in time, if I say that this point's velocity, okay, if this point's velocity, if I say, is v down, and this point's velocity is v naught down, okay, so let's say this is v1, this is v naught, and this is v2. Now all in the same direction, because velocities are vectors. So okay, if all of them are in the same direction, so basically if the centers, now understand, now I can shift this system horizontally also. So let me take the system here as horizontal, that the pulley is like this. Okay, so basically the center of the pulley is velocity or displacement or acceleration. I can take anything. Okay, let's take velocity. So velocity of the center is v naught. The topmost point where probably a string is there, the string's velocity here is, say, v1, and the string's velocity over here is v2. Now don't understand how does this come. Again, it comes because of this concept of center of mass, but you don't have to get into that right now. Just remember that the trick is that if you know this velocity, now all of them should be in the same direction, nahi to negative le lena. So this plus this, the average of these two in the same direction is equal to the center. So all you have to understand is v naught is equals to v1 plus v2 by 2, all in the same direction by number. Now this will hold true for acceleration as well. A naught is equals to a1 plus a2 by 2, even displacement for that matter. How do you apply it? We will see in one question, which again the IIT has seen once. So now let's have a look at this problem. This problem can be solved in less than 5 seconds. So the block B moves downwards with an acceleration of 3 meters per second square. Find the acceleration of block A. Okay, the answer will be 6 meters per second square. How did I do it so quickly? Let me show it to you. Everyone, please watch it for yourself. So this point is moving down with an acceleration of 3. So ye bhi 3 hoga, ye bhi 3 hoga. So this point's acceleration is 3. ठीक है, ये 3 लिख दिया. This point is connected to the ground. So this if you travel, this will be 0. So here the velocity of this point is 0. छोटा सा लिख दिया 0 to show you the direction. Now this point's acceleration is, say, a. So basically, if the acceleration of this is a, which you have to find, all I had done here was a plus 0 by 2 is equals to 3. So all you have to do is this plus this is equals to this. Okay? So what do you get? A plus 0 upon 2 is equals to 3. So a is equals to 6. Such a simple way of solving this problem. Now, can this problem be solved using the tension trick? Absolutely yes. Tension se bhi bahut easy hai. So let's have a look at the tension trick. Okay, now I'll explain the same problem using the tension trick. And sometimes when the strings are quite a lot, it's better to use the tension trick and not this. This can be used for a simple example like this. ठीक है? Now let's have a look at the tension trick. तो यहाँ पे assume कर लो कि this is one string, the tension is T. So tension will be T here also. ठीक है? So tension को mark भी कर दो on this block. So this is T. Because tension is a pulling force and the acceleration is downward. Let's say that the acceleration of this is A, which we have to find. So this is T. Look at this very carefully. So if this is T, what will be the tension here? The tension here will be what? Let's say if it is T1, and T1 on this pulley. So on this pulley it is T1 T1. So basically it will be T by 2, right? You can easily establish 2 times T1 is equals to T. So T1 is equals to T by 2. So the tension in this string is actually equal to T by 2. ठीक है, T by 2 ले लो. So now do the dot product वाला technique. Net work done by the string is 0. So ये यहाँ पे apply this dot product of tension and acceleration on all the blocks is equals to 0. So here the tension is 3 and A. So dot product क्या होगा? Minus 3T because they are in the opposite direction. T and 3. So minus 3T. And here tension and acceleration are in the same direction. So T by 2 into A. Okay. So plus T by 2 into A dot product is equals to 0. Tension cancelled. And here also you'll get A as 6 meters per second square. Now let's have a look at one more problem which can be solved in a jiffy by using the tension trick. But यहाँ पे initially here actually, यहाँ पे I shouldn't have done the problem like this. I should have taken the tension here. So it becomes very simple. T, if I took this as T, so this will be T, this will be 2T. So I will not have to deal with fractions. तो यहाँ पे let me not make that mistake. तो यहाँ पे let's actually take this tension as T. अब देखो, take this tension as T, तो ये भी T हो जाएगा. This will be 2T, right? Because it's a massless pulley. T, so the other one has to be 2T. Massless है, net force should be 0. So if here the tension is 2T, so here it will be 4T. Everyone can see this has to be 4T. So if this is 40, here it has to be 8T. Okay, so this has to be 8T because यहाँ पे 4T and 4T is acting. So this is 8T. This is the same string. Here the tension is 8T. That's it. अब tension को देके dot product से you can easily find the velocity. So here because velocities are given, so you apply the tension trick with velocity. Do this and you're done. That's it. So here the tension, everyone see. You all know because 2 is moving up, the entire thing will move down. So the velocity here will be downwards. So again, it doesn't depend. It does not depend on the direction. So basically, even if you took the velocity as up, you would have got it as negative using the same funda. So it doesn't matter. So you can take it in any direction. So, but because you can visualize this is going up by 2, the entire system will come down. Even the block B will come down with some velocity. Let's say that velocity is V. So apply this. So 8T into 2, they are in the same direction. So 8T into 2 dot product into 1, okay, plus the this will be a negative dot product, okay. So this will be minus TV because tension and velocity are opposite to each other. So minus TV is equals to 0. So यहाँ से TT got cancelled and velocity equals to 16. Such a simple way of doing this problem, and let me tell you, this problem will become a nightmare if you go via the mathematical route that the length will be constant. So don't do that. Now let's see how much can you apply here. Let's see what the next question is for all of us. I hope everyone is having fun. Please type a yo. Okay students, so this one is for all of you. Let's see how much time you take in solving this problem. So here there are multiple blocks and one block is moving down with 3. The other one is also moving down with 3. So the other one has to move up. I think all of you can visualize A, B come down, the string, they take a lot of string and because of that C moves up. Okay, so this entire thing is moving down. So the string यहाँ से कम होगा, so it will move up. So first is visualization. तो अब यहाँ पे calculate this value. So what is the best way? Whenever you have a lot of pulleys, what did I say? Whenever you see a lot of pulleys, look at tension. Tension से तुम्हारी tension कम हो जाएगी. So this is the string, this entire string में tension let's say is T. T, same string, right? So T, and here also T. And here in this string it will be 2T. And here also it will be 2T because of the pulley. So this is a pulling force, tension, and this will be 2T. ठीक है? So 2T and T. तो अब सब कुछ मिटा दो. Okay, for clarity, मिटा दो. So you know that this is T, because of which this entire thing, this was 2T and this was 2T. On the blocks, this is 2T tension here. On this, the tension is a pulling force, and here this is T. Now just do this. T dot V, summation of T dot V for all the blocks should be equal to 0. So here what is the summation? What is the summation here? 2T into 3, so minus, okay, because they are opposite, minus 2T into 3, and here also they are opposite, so minus 2T into 5, and here both are in the same direction, plus TV plus TV is equals to 0. T, 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 मर गए. Now let's have a look at this. minus 6 minus 10 plus V is equals to 0. So यहाँ से velocity will be equal to 16 meters per second. Positive आया, so it has to be upwards. So yes, there is an option, C option. So again, let's now try some more problems. Now this problem that you see, my dear students, in front of you, this is an advanced illustration, and again let me tell you, it is not very easy, it is not very straightforward, because here acceleration or velocity is not given, but force is given. But trust me, if done the right way, again first look at forces and then look at acceleration, because here you have to find the acceleration of the massless pulley. So again, be very careful here. A lot of students make a mistake. 90% of the students will make a mistake in this problem. Okay? So if this is a force F, everyone, if this is a force F, you have to tell me what is the acceleration of this pulley. Okay? So understand, this is a force. So if what did I say? If I apply a force, okay, F on a string, then the tension will also be equal to F. Why? Because if I just look at this string, if I just look at this is a massless string, right? So if I just look at this string and this is massless, if the force is F, okay, if the force is F, then here if the tension applied is T, so obviously because it is massless, F will be equal to T. Okay? So this is the tension in the string. So tension is equal to F here. So use the same funda. If the tension here is F, okay, so the tension here will be 2F. Sorry. So if the tension here is F, here it will be F by 2 and F by 2, right? So if here, because the net force should be 0, and again the tension is constant throughout. So here the tension is equals to F, here it will be T by 2, T by 2. So everyone, please have a look at what will be the acceleration of this block. Because of the tension being equal to F by 2, is mass पे, if you draw the free body diagram of this mass, okay, so here the tension is acting and tension is equal to F by 2, okay. So what is the acceleration of this block? Let's call this acceleration of this block as A1, okay. So m into A1 is equals to F by 2. So acceleration of the block is equals to F by 2m, okay. So this is the acceleration of the block. Now you can easily apply the pulley trick to solve this problem with ease. तो अब pulley को देखो. So you wanted to find the acceleration of the pulley. The center का क्या acceleration है? Let's say the center's acceleration is A, which we have to find out. Okay, and this point is connected to the ground. So the acceleration here at this point will be 0. So acceleration here is 0, and acceleration here is A1. Understand? So it is moving in this direction. So the acceleration here is A1 because of the block you found out, right? So you can easily apply the pulley technique here. A1, and this is 0, right? A1 plus 0 by 2 is equals to A. So A will be equal to A1 by 2. So what is A1? F by 2m. So this will be equal to F by 4m. So this is your value of acceleration. So the correct answer is C option. Again, kudos to everyone who could solve this on their own within seconds. So now I think enough has been done and understood. Now this is one question which I want the entire masterclass to solve on their own, and very soon we are going to discuss what is the solution of this, and which brings me to obviously what was your surprise one, which definitely will help you tremendously in your aspirations. So again the surprise is related to Newton's laws. We are launching a course at Vedantu, an amazing course on Newton's laws of motion, and I'll be talking about that very soon. But before that, please make a note of this question. Please take a picture here. So there are many pulleys, and this big block is moving with a velocity of 1 meters per second, and you have to find what is the velocity of this block B moving here. So now this is fixed, okay? So this is not moving, this is fixed, and because when I move block A, what will be the velocity of block B with respect to ground, obviously. So find that. The options are 1, 3, 4 and 5. Okay, you can continue to do that. And now please be extremely attentive. Students, be all eyes, all ears, because now I'm going to disclose what the first surprise is. So the first surprise will be available to all of you on this very simple link. Please make a note of this. It is VDNT, matlab Vedantu without vowels. It is vdnt.in, all in small, /Newton. Everything is small. vdnt.in/Newton. So here you can avail this amazing course, which will obviously be of close to 11 hours. And here we'll be discussing in detail many such techniques and how we can solve Newton's laws of motion like a pro. Okay, so now this will help you in your JEE Advanced, NEET, and obviously it will give you a very superior edge over everyone else. Now, what will be covered? First, let's cover what will be covered in this. So again, as I said, we'll be discussing basic forces. We'll also be having spring force and the concept of weighing machine, how we can, because there's a lot of confusion how do weighing machines work when we are in an accelerated frame of reference, motion on an inclined plane, very simple concepts and tricks related to that. String and pulley based problems, you saw some tricks, there are plenty more to go about. There is constrained motion, you saw some examples of constrained motion, but we will see a lot of them in this course. We will also be looking at pulley block constrained motion tricks. I think you saw 2 tricks today. Apart from that, we also have pseudo force. So again, pseudo force and how to apply pseudo force in normal problems, we will be having a look at that. And again, we will be concluding with the Hooke's law, the string cut problems, which obviously are very scoring and very easy. Now these are free marks, but in JEE Advanced, these are primary. You see them quite a lot in JEE Advanced and some advanced problems of NEET, string cut problems. And again, the last one, which again is very simple, but we will see how we can derive for composite strings like never before. So when I say like never before, you will see in the master classes. So again, students, please make a note of this because many of you will come back to me on this. I'm also sharing my email address on which I'm very responsive. It is namo@vedantu.com. So what you can do is, once you enroll for this course, my dear students, on this link vdnt.in/Newton. So once you do that, please send me a snapshot, and once you send me a snapshot on my email address, what I will do is I will unlock the second surprise for you. So again, what the second surprise is, we will see in a bit. First, let me show you how you can become a part of this life-changing course. So everyone, let's have a look. So I go to my browser, I go to please watch this, vdnt.in/Newton. Okay, everything in small, and when I hit enter, so this redirects me to a secure page on Vedantu, and here you can clearly see on Vedantu Master Classes, you can pay a very discounted price here and enroll for this course. Again, let me tell you, the seats are limited, so please hurry up because this course is starting very soon. And so that's about it. I'll again repeat, the link is vdnt.in/Newton. It cannot be simpler. It is vdnt.in/Newton. So once you enroll, just send me an email. Just send me the snapshot on namo, as in Narendra Modi, namo@vedantu.com, and I will unlock the second surprise for all of you. So again, students, what is the second surprise? So I think before I tell you anything, let me tell you what the second surprise is, which, as I stated, it is very difficult for you to even begin to imagine how much it will help you, not just in your life-changing exams, but even beyond. So again, it is an MCQ module which I share with all my kids. Again, being the proud inventor of Turbo Math, there is a module which I share. Again, that is for all my students, and it is completely free of cost. But again, find the answer to this right away. So let me tell you, even if you're good, even if you're fast in type, so good. So that is about it. Let me also show you one more example before we can actually get back to that question. So have a look at this problem also. Can you solve this question in less than 10 seconds? So again, the answer to that is the second surprise. Once you obviously enroll for the first surprise, I'm again repeating, please send me a snapshot, just take a picture that you've enrolled and send it to me at namo@vedantu.com, and I will be sharing the second surprise with all of you. So now let's get back to the question that we were on. So this is the problem that we were on, and here we had to find the velocity of block B when we move the block A with 1 meters per second. Now there are many ways of solving this problem. One is using the length of the string, which is very simple in this case, or you can also use the tension trick here. You can also use the pulley trick, but again, pulley trick will not be that easy. It will take some time. So I would recommend go via the tension trick. So which is the biggest string, which you see everywhere. So this is the biggest string and many tensions. So take the tension here as T. So let's say that the tension here is T. So T, 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 T throughout T. So this will also be T. It's the same string. So the tension acting on this block is just plain T. On this block, so this is TT. So to balance it, the tension in this string will be 2T because pulley is massless, the forces have to be balanced. So here on this block, because of this string, the force will be 2T. On this block, the force will be 2T. On the pulley, it will be 2T pulling this side because obviously in a string, this is 2T, this is also 2T. So don't get confused that how does this balance on, because this is the force on the block, not on the pulley. So this is 2T, 2T and T. So what is the net force on A? So on A, the net force is 5T. Okay? See how simple this becomes. Very complex problems open up like this. This is T and here the velocity is V and here the velocity is 1 meters per second. तो डॉट प्रोडक्ट कर लो दोनों का इसका तो टीवी हो जाएगा समेशन ऑफ द डॉट प्रोडक्ट इसका -5 हो जाएगा -5t 5t into 1 equals to 0. So here velocity will be equal to 5. So no confusion, the correct answer is 5. One more problem which I like, and this problem has been debated over a lot of forums. So I would like to share this with all of you. So this problem, by the way, in front of you can be solved using the tension trick. It can be solved using the pulley trick. It can be solved mathematically using calculus and the length of string constraint. Try to solve this question using the tension trick also. Try to do it yourself. I will tell you one way of solving it, but you have to solve it via the tension way. And let's see if you can do that. So here, see how I will just solve it for you in 1 second is if this point's velocity is 10, this point's velocity down is 0 because it is connected here. So I can easily find this velocity. So ये velocity अगर मैं इसको v ले लेता हूँ, so I can easily say left plus right by 2, all in the same direction, right? v plus 0 by 2 is equals to 10. So v is equals to 20. तो ये v20 इसका velocity है, understand? So this is this velocity. So this is 20. So this is 20. So this will also be 20, and this will also be 20. So this is the vector way. So if this boy's velocity, this mass's velocity is VA, and we can visualize, okay, killer visualization is needed. A we know, okay, the barb vector will be here because A is moving here. This is just one of the component of VA. So you can easily solve it like this: VA cos 37 degrees is equals to 20. I know this is the easiest way to solve this problem, but I would recommend that can you solve this problem using the tension trick. So try that out. If you're able to do that, let me know in the comments. So this will be VA into 4 by 5 is equals to 20. So 4 5s are, so your answer should be 25 meters per second. So do solve this, and many of the students also get a wrong answer here, which is 16 meters per second. Understand, this is not the right answer. It has been debated in a lot of places. Many people debate that the answer will be 16 meters per second, but let me tell you, using multiple techniques, I can tell you that the answer will be 25 meters per second. So I hope this helps students. Again, I would, from the bottom of my heart, I would really like to thank all of you for such amazing response in kinematics 1 and 2. And again, with that, I have come back with Newton's laws of motion. And I hope to see all of you in my master classes on Newton's laws. It is one of the most interesting, and again, as I say, it is the place from where physics starts. Okay, so for that, let me again repeat it for all of you. The important instruction was, just a minute, yeah, this is the link vdnt.in/Newton. Just go here, enroll for the course. You will enroll for the course just for $9.99, and then once you enroll, please send me the snapshot at namo@vedantu.com, and I will unlock the second surprise for you. We will also add you to a WhatsApp group which we'll create for all the enrolled students, and there obviously post that the classes for the same will start on Vedantu. Again, Vedantu Master Classes, which is the fusion of the best teachers and the best of technology. So again, with that, see you soon and love you all. Take care. Bye.